The National Electrical Code (NEC) defines diversified load as the portion of the total connected load that is unlikely to be demanded simultaneously. The NEC allows for the use of diversified loads in calculating the service size for multi-family dwellings. This allowance acknowledges that the full connected load of all units is improbable to operate at maximum capacity at the exact same time. For multi-family dwellings, the NEC mandates the service size to be calculated based on the diversified load. The diversified load is determined by applying specific diversity factors to the connected load of each unit type. Diversity factors represent the percentage of the connected load that is considered diversified. These factors vary depending on the type of unit. NEC Table 220.87 provides diversity factors. Let's look at how a 700 amp service size might be justified. In a hypothetical scenario, an engineer calculates the diversified load to be 691 amps. Given this value exceeds the maximum allowable diversified load of 600 amps at 120/240 volts, single phase, as per Table 220.87, a 700 amp service size would be required. So based on the diversified load calculation, the main circuit breaker size of 700 amps is appropriate to accommodate the calculated load of 691 amps for the residential units. The use of diversified loads is an accepted practice within the NEC for calculating service sizes in multi-family buildings. NEC Section 220.87, titled Determining Existing Loads, permits using actual maximum demand data to determine the existing load of a dwelling unit under specific conditions. Firstly, the demand data must be available for a minimum of 1 year. Secondly, the demand data must be recorded at intervals not exceeding 15 minutes. The NEC permits the use of this demand data to determine the existing load rather than calculating it based on the standard method outlined in Article 220. This method is applicable when increasing the size of existing services or feeders. The NEC allows using load calculations or actual load measurements to determine the existing load. The calculation method involves determining the total connected load and applying the appropriate demand factors from Article 220. Load measurements involve recording the actual current or power demand over a period of time. When using load measurements, the NEC requires the measurements to be taken over a period of not less than 30 days. It also requires the measurements to be taken under normal operating conditions. The NEC does not permit using load measurements taken during periods of abnormal conditions such as equipment failure or extreme weather. When calculating the existing load, the NEC requires that the calculation include all loads that are connected to the service or feeder. This includes lighting, appliances, motors, and any other equipment that draws power. The NEC also requires that the calculation include any loads that are likely to be connected to the service or feeder in the future. When using load measurements to determine the existing load, the NEC requires that the measurements be taken at the point where the service or feeder enters the building or structure. This ensures that the measurements accurately reflect the total load in the service or feeder. The NEC also requires that the measurements be taken with calibrated instruments that are accurate to within plus or minus 2%. The NEC does not permit using instruments that are not calibrated or that are not accurate. When determining the existing load, the NEC permits the use of demand factors to reduce the calculated load. Demand factors are based on the assumption that not all loads will be operating at the same time. The NEC provides demand factors for various types of loads, such as lighting, appliances, and motors. The NEC also permits the use of load diversity to reduce the calculated load. Load diversity is based on the assumption that not all loads will be operating at their maximum demand at the same time. The NEC does not provide specific load diversity factors, but it does permit the use of engineering judgment to determine appropriate factors. When increasing the size of an existing service or feeder, the NEC requires that the new service or feeder be sized to carry the calculated load. The calculated load must include the existing load, any new loads that are being added, and any future loads that are likely to be added. The NEC also requires that the new service or feeder be sized to provide adequate capacity for future expansion. When increasing the size of an existing service or feeder, the NEC permits the use of overcurrent protection devices that are sized to protect the new service or feeder. The overcurrent protection devices must be sized in accordance with the requirements of Article 240. The NEC also permits the use of ground fault protection devices that are sized to protect the new service or feeder. The ground fault protection devices must be sized in accordance with the requirements of Article 230.95. NEC Table 220.42 provides demand factors for dwelling units. This table allows for a reduction in the calculated load based on the number of dwelling units served by a single service or feeder. The demand factors in Table 220.42 are based on the assumption that not all dwelling units will be using their full electrical load at the same time. The more dwelling units served, the lower the demand factor. For example, if a service supplies only one dwelling unit, the demand factor is 100%. This means that the calculated load for the service must be equal to the sum of the connected loads in the dwelling unit. However, if a service supplies 3 or more dwelling units, the demand factor is reduced to 45%. This means that the calculated load for the service can be reduced to 45% of the sum of the connected loads in the dwelling units. The NEC permits the use of these demand factors to reduce the size of the service or feeder conductors. This can result in significant cost savings, especially for large multi-family dwellings. The NEC specifies that these demand factors apply only to the general lighting and receptacle loads in dwelling units. They do not apply to other loads such as electric ranges, clothes dryers, or air conditioners. These other loads must be calculated separately and added to the calculated load for the general lighting and receptacle loads. The NEC also specifies that these demand factors apply only to dwelling units that are part of a multi-family dwelling. They do not apply to single-family dwellings or to individual dwelling units that are not part of a multi-family dwelling. The demand factors in Table 220.42 are based on historical data and are intended to provide a safe and reliable estimate of the actual load that will be placed on the service or feeder. However, it is important to note that these demand factors are not a guarantee that the actual load will never exceed the calculated load. It is always possible that the actual load could exceed the calculated load, especially during peak periods of usage. For this reason, it is important to use good engineering judgment when applying these demand factors. It is also important to consider the specific characteristics of the dwelling units being served, such as the number of occupants, the types of appliances used, and the lifestyles of the occupants. If there is any doubt about the appropriate demand factor to use, it is always best to err on the side of caution and use a higher demand factor. It is important to consult with a qualified electrical engineer to ensure that the service or feeder is properly sized for the anticipated load. In multi-family dwellings, there are usually several loads that can be considered non-coincident. These loads are not likely to be used at the same time, so the demand can be reduced when calculating the total service load. Some common examples of non-coincident loads in multi-family dwellings include electric ranges and ovens, clothes dryers, air conditioners, and electric water heaters. The electric ranges and ovens are typically used for cooking meals. However, they are not usually used for extended periods. Clothes dryers are used to dry clothes, but they are also not typically used for extended periods. Air conditioners are used to cool the dwelling units during the summer months. However, they are not always used at the same time. Electric water heaters are used to heat water for domestic use. However, they are not always used at the same time. The NEC allows for the use of demand factors to reduce the calculated load for these non-coincident loads. The demand factors are based on the assumption that not all of these loads will be used at the same time. For example, the NEC allows for a demand factor of 65% for electric ranges and ovens in multi-family dwellings. This means that the calculated load for the electric ranges and ovens can be reduced to 65% of the total connected load. The NEC also allows for a demand factor of 75% for clothes dryers in multi-family dwellings. This means that the calculated load for the clothes dryers can be reduced to 75% of the total connected load. The NEC does not provide specific demand factors for air conditioners or electric water heaters in multi-family dwellings. However, it does allow for the use of engineering judgment to determine appropriate demand factors. When using engineering judgment, it is important to consider the specific characteristics of the dwelling units being served, such as the number of occupants, the types of appliances used, and the lifestyles of the occupants. It is also important to consider the climate in which the dwelling units are located. In general, the demand factor for air conditioners will be higher in hot climates than in cold climates. Similarly, the demand factor for electric water heaters will be higher in areas where water is expensive than in areas where water is inexpensive. It is important to consult with a qualified electrical engineer to ensure that the service or feeder is properly sized for the anticipated load. When considering non-coincident loads in multi-family dwellings, it is important to remember that the NEC is a minimum standard. It is always possible that the actual load could exceed the calculated load, especially during peak periods of usage. For this reason, it is important to use good engineering judgment when applying demand factors. It is also important to consider the specific characteristics of the dwelling units being served, such as the number of occupants, the types of appliances used, and the lifestyles of the occupants. If there is any doubt about the appropriate demand factor to use, it is always best to err on the side of caution and use a higher demand factor. The NEC provides guidance on calculating the service size for multi-family dwellings in Article 220. Firstly, calculate the general lighting load. For dwelling units, the general lighting load is calculated at 3 volt-amps per square foot. This value covers general illumination and small appliance loads. Secondly, determine the small appliance and laundry loads. The NEC requires a minimum of 2 20-amp small appliance branch circuits for the kitchen and dining areas in each dwelling unit. A load of 1500 volt-amps is assumed for each of these circuits. Additionally, a separate 20-amp laundry circuit is required, also rated at 1500 volt-amps. Thirdly, calculate the individual loads. For appliances like electric ranges, ovens, dryers, water heaters, and air conditioners, the NEC provides specific methods for calculating their demand. For example, Table 220.55 provides demand factors for electric ranges based on their rating and quantity. Fourthly, apply demand factors. After calculating the individual loads, apply the appropriate demand factors from Article 220. These factors account for the fact that not all appliances and equipment will be operating simultaneously at their maximum rating. Table 220.42, as discussed earlier, provides demand factors for the total number of dwelling units. Fifthly, calculate the total service load. Sum up all the individual loads after applying the appropriate demand factors. This will give you the total calculated service load in volt-amps. Sixthly, determine the service size. Divide the total calculated service load in volt-amps by the system voltage to determine the required service current in amps. The service conductors and overcurrent protection devices must be sized to handle this calculated current. The NEC requires that the service entrance conductors have an ampacity equal to or greater than the calculated service load. The overcurrent protection device, such as a circuit breaker or fuses, must also be rated to protect the service conductors. It is important to note that the NEC is a minimum standard. Local codes or utility requirements may be more stringent. Always check with the local authorities having jurisdiction to ensure compliance with all applicable regulations. In some cases, the utility company may require a larger service size than what is calculated based on the NEC. This may be due to their specific grid conditions or future load growth expectations. Additionally, the NEC provides alternative methods for calculating the service size in certain situations. For example, Section 220.82 allows for a simplified calculation method for new dwelling units with a calculated load of 100 amps or less. The NEC also provides guidelines for calculating the service size for buildings with mixed occupancies, such as apartments with commercial spaces. In these cases, The load calculations for the dwelling units and the commercial spaces must be performed separately and then combined to determine the total service load. It is always recommended to consult with a qualified electrical engineer to ensure that the service size is properly calculated and that the electrical system is safe and reliable. Calculating the service size for multi-family dwellings can be a complex process. However, by following the steps outlined in the NEC and consulting with a qualified electrical engineer, you can ensure that the electrical system is properly sized and meets all applicable codes and regulations. The correct calculation of service size ensures the safety and reliability of the electrical system in the building. Undersized services can lead to overloaded circuits, voltage drops, and potential fire hazards. Oversized services can result in unnecessary costs and wasted energy. Therefore, it is crucial to accurately calculate the service size based on the anticipated load and to comply with all applicable codes and regulations. When determining the appropriate service size for a multi-family dwelling, several factors should be considered. These factors include the number of dwelling units, the size and type of appliances used in each unit, the diversity of the loads, and the potential for future load growth. In addition to the NEC, there may be other codes and regulations that apply to the electrical system in a multi-family dwelling. These may include local building codes, fire codes, and accessibility codes. It is important to be aware of all applicable codes and regulations and to comply with them. The electrical system in a multi-family dwelling is a critical infrastructure that provides power for lighting, appliances, and other essential equipment. It is important to ensure that the electrical system is properly designed, installed, and maintained to ensure the safety and reliability of the building and its occupants. Regular inspections and maintenance can help to identify and correct potential problems before they become serious. It is also important to educate the occupants of the building about electrical safety and to encourage them to report any problems or concerns to the building management. By working together, building owners, managers, and occupants can ensure that the electrical system in a multi-family dwelling is safe, reliable, and efficient.